Hello and welcome to this tutorial on reacting mass calculations. So we'll be looking at how to use the moles of a substance to calculate the mass of reactants and or products in a chemical equation. Just before we go on, it will be quite a long video. I'm going to go through quite a few worked examples. However, if you want to stop and then work through the answers yourself and check them as I go, that's fine. Also, there are some questions towards the end of the tutorial and you're welcome to pause those questions, work them through and then check your answers at the end. Before beginning this tutorial, please do have a check through the following information and make sure that you're able to balance a chemical equation, calculate the relative formula mass or the MR of the compound, and also how to calculate the amount of substance in moles. You'll also find it useful if you've got a calculator and a periodic table of elements. I'm going to be using one from the GCSE specification that has been rounded to the nearest whole number for the atomic masses. In our first example here, we're being asked to calculate the mass of iron sulfide produced when 28 grams of iron reacts with excess sulfur. So the iron sulfide is the FeS on the right hand side of the equation. Obviously the iron is the Fe and the sulfur is the S, and we're being told here that we have an excess. This just means that more of the sulfur is being used than is actually needed for the reaction, and that just means that all of the iron will react. So the first thing that we need to make sure we have is a balanced equation. This is going to be really important later on when we look at ratios of reactant used and product formed. Now I can see here that this equation actually is already balanced, as there's one atom of iron on the left hand side, one atom of sulfur on the left hand side, and again one atom of iron and one atom of sulfur on the right hand side. So I can either leave those spaces blank, or if I wanted to, I can put a 1 on each of those. If it helps you to put 1s in, just feel free to put 1s or leave them blank. Now the next thing to do is to summarise all of the information from the question and the equation given. I think this really makes it easy to understand. So if we look, we've got the iron and the iron sulfide. We're going to ignore sulfur because we're not being asked about it. All we're told is that there's an excess, there's more of it than we need. Okay, so in the table we're going to fill in the ratio of iron to iron sulfide. So we can see here that the ratio is 1 mole of iron reacts to make 1 mole of iron sulfide. So I'm going to fill that in to the table. The next thing we need is the mass of each substance that we're being asked about, and the mass of iron here is 28 grams. So I'm going to write that in to my table, and then for iron sulfide, that's the mass that I'm trying to calculate, what I'm trying to work out, so I'm going to leave that now. The next thing is I need the atomic masses or the formula masses, so the AR or the MR of each of the substances involved. So for iron, that's easy, that's an AR because it's an atom by itself, and if I look that up on a periodic table, that's 56. And for iron sulfide, I need to do a little bit more work. Now that's going to be an MR because it's a formula, so that's going to be 56 from iron plus 32 from sulfur, which gives me an MR of 88. Okay, now what I need to do now is I need to look at calculating the number of moles. So number of moles equals the mass divided by the atomic mass or the formula mass, the MR, depending on what I'm looking at. Now for iron, this is going to be an AR because it's an atom. So I'm going to divide 28 grams by the atomic mass, which is 56, which is going to give me 0.5 moles. Again, looking up to the equation or the ratio from the equation, 1 mole of iron will react to make 1 mole of iron sulfide, but I'm not using 1 mole, I'm using 0.5, so that means that on that 1-to-1 ratio, 0.5 moles of iron will produce 0.5 moles of iron sulfide. I'm then going to look here and I'm going to look at how to calculate the mass, which is the only thing that I'm missing now, and that's what I'm being asked to do in the question. And mass equals the number of moles multiplied by the AR, so the atomic mass, or the MR if it's a formula. Now for iron sulfide, FeS, that's going to be an MR, which I've just calculated as 88. So this is going to be the number of moles, which is 0.5, multiplied by the MR, which is 88, which is going to give me a mass of 44 grams. Really important that I do include the G for grams there, as I'm being asked about a mass. In our second example here, we're being asked to look at the reaction between magnesium and oxygen, and we're being asked to calculate the mass of magnesium oxide, the MgO, produced when 2.4 grams of magnesium, Mg, is burned. When it burns, it just reacts with oxygen in the air. The first thing I'm going to do, just like in the previous example, is I'm going to quickly balance the equation. So that's going to be 2MgO needs 2Mg. So this just means that 2 moles of magnesium reacts to form 2 moles of magnesium oxide. And again, just like in the previous example, I'm going to summarize that information into a table underneath. I'm going to be ignoring the oxygen, the O2, because I'm not being asked about it and I have no information for it. So first thing to do is to look at the ratio from the equation. And here I've got 2 moles of magnesium reacts to form 2 moles of magnesium oxide. Okay, this is where we need to do a little bit of simplifying of the ratio. So as it says there, 2 to 2. I'm going to simplify that now down because that's going to be much easier later. I'm going to simplify that to 1 to 1. Now that I've used that 2 magnesium and the 2 MgO and simplified it down to 1 to 1, I don't need to use it again. Okay, so the next step, I'm going to fill in the masses that I know, and I'm being told here that I've got 2.4 grams of magnesium. I don't yet know the mass of magnesium oxide produced, so I'm going to leave that blank. Again, going to look down and find the atomic masses or the formula masses. And because magnesium is an atom, I'm going to use its atomic mass, which from the periodic table is 24. And for magnesium oxide, you need to do a little bit more work, and that one is 1 magnesium plus 1 oxygen, so that's 24 plus 16, gives me an MR of 40. Again, just like previously, the next step is to look at the moles, and the moles is the mass divided by the AR, the atomic mass, or the MR if we have the formula. So for magnesium, it's the atomic mass. So the mass from the question is 2.4 grams divided by its atomic mass, which is 24, which now is going to be 0.1 moles. Okay, now looking back to the ratio, which was 2 to 2, but I simplified down to 1 to 1. So that means that 1 mole of magnesium makes 1 mole of magnesium oxide. I'm not using 1 mole, I'm actually going to be using 0.1 moles. So 0.1 moles will make 0.1 moles of magnesium oxide. Again, need to go back up to the mass now, and we said earlier that mass equals the number of moles multiplied by the AR or the MR. It's going to be the MR in this respect because it's a formula which has an MR of 40. So the moles is 0.1 multiplied by the MR of 40, which means that we will have a mass of 4 grams. Again, just like previously, putting in the G for grams because we're being asked to calculate a mass. Now on to our third example. Seeing as we've already looked at 2 examples, if you want to stop the video and then use the information in the question, work it out, and then check your answers and you're working out with my answers at the end, absolutely fine. If not, then just don't pause it, just carry on listening and we'll work it through. Okay, so this example we're being asked to calculate a mass of sodium oxide, which is the Na2O, produced when 46 grams of sodium is reacted with aluminium oxide. Again, the first step that we need to make sure that we've done is to balance the chemical equation. So I'm just very quickly going to balance this equation, so that will be 6, 3 and 2. Once we've balanced the equation, we're going to summarise all the information that we know into a table below. As you can see, I've left the spaces at the top blank. I'm just going to go through with you why we write the substances in that we do. So the first substance I can see in the question is the mass of sodium oxide. That's the Na2O. And then the other thing that I'm being told about is the sodium, the Na. The aluminium oxide, I'm not told anything about it, or I'm not asked to do anything with it, so I'm going to ignore the aluminium oxide, and I'm also going to ignore the aluminium. Okay, so in the first part of the table I'm going to write Na for sodium, and I'm going to write Na2O for sodium oxide. My ratio from the equation is 6 moles of sodium reacts to form 3 moles of sodium oxide. Now you might find this ratio tricky to use, so we'll write it in first of all, 6 to 3. Then what I'm going to do is I'm going to simplify this down, and I'm going to make this from, I can see 6 to 3 is the same as 2 to 1. Simplifying that ratio will just make things a lot easier later on when I come to work out the moles. Now I'm going to go through the table. I'm going to fill in what I can from the question and the equation. So the mass from the question, I'm calculating the mass of sodium oxide, so we'll leave that blank. And I'm also told that I've got 46 grams of sodium. Atomic masses or formula masses are easy to find. For sodium, it's going to be an atomic mass because it's by itself, and that from the periodic table is 23. And then for sodium oxide, I need to do a little bit more here, but using the masses from the periodic table, I can see that there are 2 sodiums and 1 oxygen. So adding those together, that's 2 times 23 plus 16, which gives me an MR of 62. Now going back, I need to calculate the moles of sodium, and as we said before, moles equals mass divided by the AR or the MR. I'm going to use the AR here for sodium. It's atomic mass because it's by itself, as we said. So the mass is 46 grams divided by 23, which gives me 2 moles of sodium. Go back up to the ratio, and the ratio that we simplified earlier was 2 to 1. So we have 2 moles of sodium. As the ratio says, it will be 2 moles of sodium will make 1 mole of sodium oxide. Now we can go back and we can use this information to work out the mass of sodium oxide, and mass in this respect will be the number of moles multiplied by the MR of sodium oxide. So the number of moles is 1 mole multiplied by 62, its MR, will equal 62 grams of sodium oxide produced. Here we have another example. I'll be working this one through again, but if you want to stop it and check your answer at the end with mine or work it through with me, that's fine. If you want to do it by yourself, just stop the video now. Okay, so in this example we're being asked to calculate the mass of iron produced when 80 grams of iron 3 oxide reacts with an excess of carbon. If you remember from the first one that we did, the excess, carbon monoxide, you'll remember that the excess just means more than we need to ensure that the reaction happens. Okay, first step again is to balance the equation and balance it properly. So I'm just going to do that very quickly here. 3, 3 and 2. Okay, once we've got the balanced equation, we're going to summarize again all of the information underneath. And the 2 substances we need to put into our table now are the iron, as we're being asked to calculate the mass, so that's on the right hand side, so we're going to put it here, and the iron 3 oxide, which is the Fe2O3. Okay, the carbon monoxide and the carbon dioxide I'm going to ignore because I don't know anything about them and I can't work anything out yet. Okay, now from the equation then I need to look at the ratio. Again, there's no number in front of Fe2O3, the iron 3 oxide. I can put a 1 in if I want to, just to make things easier for me to see, or I can leave it blank and just assume that there is only 1 mole. So the ratio from the equation there is 1 to 2. So 1 mole of iron 3 oxide, Fe2O3, will produce 2 moles of iron. Let's go through, and as we did before, fill in any masses that we know. So 80 grams of iron oxide, and we're going to use that to calculate the mass of iron produced, so I'm going to leave that as it is. We're going to look through and work out any atomic masses, ARs, or formula masses, MRs. So Fe2O3 will mean that I need to add together 2 atoms of iron, each with a mass of 56, plus 3 atoms of oxygen, each with a mass of 16. The total of that equals 160. And then for iron, I need its atomic mass, just a mass of 1 of those. I don't need the big 2 because I'm only using that for the ratio, which is 56. Okay, look through, how can I work out the moles? So again, the moles is the mass divided by the AR or the MR. Because I'm looking at iron oxide, Fe2O3, I'm going to use its MR here, which is 160. So I'm going to do the mass, which is 80 grams, and divide that by its molecular mass is MR, is RFM, of 160. So 80 divided by 160 is 0.5 moles. Now, if we look back up to the ratio from the equation, it's 1 mole of Fe2O3 will make 2 moles of Fe. So we're using 0.5, so 0.5 times by 2 will make 1 mole. So it's going to be 0.5 times by 2 equals 1 mole. Now I know that 1 mole is formed. Look back, look at its atomic mass of iron, which is 56. And as we said before, mass equals moles multiplied by AR here, because it's iron, it's 56, it's by itself. So this is going to be 1 mole multiplied by the AR, the atomic mass of iron, is going to give me 56 grams. This is going to be the final worked example that I'm going to work through. Again, stop it now if you want to, and then check you're working with my answer as you go. Okay, in this final worked example then, we're being asked to calculate the mass of water produced when 16 grams of methane is burned in excess oxygen. Again, excess, we don't need to worry too much about that, we just know that it's more than we need. Now, some people may be struggling with this and thinking, methane, I've never come across this before, I don't know what that is. However, if you're struggling to think about which substance it might be, look at the ones that you do know. O2, there on the left, you should recognise as oxygen. On the right, CO2, hopefully you'll recognise as carbon dioxide. And H2O, you should recognise as water, meaning that the CH4 on the left there must be the methane, because it's the only one that we don't recognise. So methane is CH4. Okay, again, first step, make sure that our equation is balanced. So I'm just going to quickly balance this, and that's 2O2 and 2H2O. Once we've got the balanced equation, we're going to summarise everything in the table just to make things easier. And the only substances I need to worry about in my table are the CH4, the methane, and the water. The water goes on the right hand side because that's what I'm producing, and the reactant of CH4 goes on the left hand side there. Okay, my ratio from my equation, again, if you want to, you can pop a 1 in there because there's no big number. O2 I can ignore, and CO2 I can ignore now because I'm not being asked anything about them. So my ratio here of CH4 to H2O is 1 to 2. I'm going to look across and see if I can fill in any of the masses, and I'm told that I'm calculating the mass of water, so I'll leave that for now, and 16 grams of methane has been used, so that's 16. Now I need to look for atomic masses ARs or formula masses MRs. Now I'm looking at CH4 and H2O, so they're both going to be MR. So to work out CH4, methane, that's going to be 12 plus 4 times hydrogen, each having a mass of 1. So the total of that is going to be 16. And then for water, there are 2 hydrogens, each with a mass of 1, plus this 1 atom of oxygen with a mass of 16. So this is going to be 18. Now I'm going to work out the number of moles of methane, and we know that moles equals mass divided by the formula mass mR here, because we don't have any atoms by themselves. So if I take those numbers, 16 grams, divided by the mR, which I said before was 16 for methane, and that's going to give me 1 mole. Now, looking across, then I can see that the ratio is 1 to 2. CH4, 1 mole makes 2 moles of water. So now I just need to take my 1 times it by 2, and that's going to give me 2 moles of water produced by 1 mole of methane. And then I need to look back the mass. So mass equals moles multiplied by mR. And for water, that's going to be 2 moles formed multiplied by 18, which is mR, which equals 36 grams. The next couple of pages here are some questions that I've put together, so some self-study questions. You will need to balance the equations and then work them through and see what answer you get. If you want to pause them now, pause it, work out the answers. The answers are at the end of the video, so you'll need to go through and find which answer you need. So the next slide is also some questions, and then the slides after that are all questions, sorry, the answers. Again, if you have any questions or you have any comments, please do leave them underneath the video. Good luck, see you again soon.